Hello everyone, welcome back to the channel. Today we are going to understand pod-to-pod communication in Kubernetes. We will do a full hands-on demo. By the end of this video, you will clearly understand how pods communicate using services and DNS and why pod IPs should never be used directly. So pod IPs can change anytime during restart, rescheduling or scaling. So the big question is how pod IPs, if pod IPs is changed, how do pods communicate reliably? So the answer is Kubernetes services. So yeah, let's prove that practically. So what we need to do first, we are going to create two backend pods that running Nginx, and both pods have same label, that is app backend. So labels are extremely important because services don't work with IPs. They work with labels. So now I will apply both pod manifest files and create those manifest file and verify them. So by using the command kubectl get pods -o wide, we can see each pod IPs. So different IPs pod, we can see that using this command kubectl get pods -o wide, and these IPs are not guaranteed to stay the same. So firstly, we can check pod to pod communication in Kubernetes using the IPs. And by using the IPs, what will happen if the pod IP change? So we can do this practical firstly, and then we can do pod to pod communication with the IPs first, and then after that we can do the pod to pod communication using the service. So let's create the manifest file. So I'm creating the first YAML file using the nano backend pod 1.yaml, and then paste the content of the file. So here I use the kind as a pod, version is v1. The metadata, the information is name of the pod is backend pod 1. Labels, we are setting it to use these labels in services. That's why we are using these labels here. So the labels is app is backend. Then the containers name is name of our containers. The pod is NGI. Then the name of containers is Nginx. The image we are taking for this container is Nginx, and ports we are setting app. The container port is 80. We are type the control X, S, and then this manifest file are created. We can check this using the cat backend. So yeah, and uh then we need to apply this manifest file using the command. So we have the one file, right? Backend pod.yaml, and how we can apply these changes. So that will create the pod. So kubectl apply -f and then the YAML file name. There is another command like kubectl create -f and the YAML file name. But this command is used to, if we are creating the YAML file, writing it on the first time, then we can use this command. But we generally prefer the kubectl apply the -f and the YAML file name, because this command is used to create the pod and also used to run the YAML file and also used to update the YAML file as well. But create command is just only used for the first time. So that's why, and if we uh, do the changes, means use this create command again and again, then it's gives an error. So we can check it. What I am saying, kubectl create -f, and then so it's creating the one pod kubectl get pod. Using this command we can check the pod. So This is the backend pod. We are setting it and its status is running. But if we again running this YAML file using the same command, it gives an error. So let's see, because let's see, this is the error from server already exists. Error when creating backend YAML pods already exists. That's the error we are getting when we are using the kubectl create -f backend pod.yaml, because it is used for the first time only. But if we use kubectl apply -f and then backend pod1.yaml, then yeah, I think I miss it. Cube kubectl kubectl, yeah, my bad. So what is saying that the annotation which is required by kubectl apply should only be used in resource created declarative by other kubectl create. Okay, so our pod is created, but if we uh I think our pod is created, right? So yeah, there is a missing something. I don't know what is this wording. We can check back again. I think. Okay, check here that we did not get any error. It's saying pod hyphen backend dot pod one is unchanged, means there is a no changes in the YAML file itself. But if we do the changes here, then it should not be getting, we are not getting this error, that is this already exists, the pod is already exists. We are by using the kubectl apply, it's going to create also and apply also. So yeah, that's the purpose of kubectl apply -a backend pod.yaml file command. So yeah, we are going to clear this terminal and then we are going to create the another pod using the same, with the same configuration, with the same command. Just going to change this and we can check there are creating the two pod is creating the one pod, but we are see that we have the two pods are abandoning 1 and 2. Now what we are going to create, so we can check the pod IPs using the command kubectl get get pods -o white. So we are getting the pod IPs. So this is the IPs. This is now the IPs of pod 1 and this is the pod 2. But we can going inside of the pod 1. So let's me create the service. For this we are creating the service first. Oh, okay, sorry. We are firstly checking with the pods, right? So yeah, we can check it. We are going to inside the pod 1 kubectl exe hyphen it and then the pod name hyphen slash bin slash bash. We are inside the pod 1 and using the curl command we are checking the connectivity with the pod 2. Yeah, so we are getting the response that welcome to the Nginx. So here we can check the connectivity. Here we are successfully did the pod to pod communication using the pod IPs. Only the pod IPs. But what if we are deleted the pod? We are inside the pod 1, right? But what if we deleted the pod 2? So we are again checking is port is deleted or no. So see, port 2 is deleted. We are creating the port 2 and then checking again the port is created or no. So port 2 is creating. Let's wait for some minute or second. Now what happened? Port 2 is created, but we are if we type this command kubectl get ports -o wide, is that we are getting the same IPs? No, we does not get the same IPs, like 10.1.0.15. Let's check that using the command kubectl get ports -o wide. We can see that the IP of port 2 are changed. Then if we are going to inside kubectl execute -it, then the port 1 name --bin/bash, we are inside of the port 1, and if we type the command using the curl and then the IPs of the IPs, the first IP that we are use here, that is this. This is not working because this is not going to work, right? Because the port second IP are changed. So this is not the good way to do the port to port communication. That's why we need to use we need to do the port to port communication using the service. So we are getting the error like fail to connect with this IPs after could not connect to server because the pod IP are changed. If we are deleted, restarted any pod, then the pod IPs are going to change. So what is the purpose of that? We are going to create the service. So for the service, we are creating the same method using the nano, creating the service, that is backend service.yaml, and pasting this configuration. That kind is a service we use for the creating the backend pod. Then we use the service. We use the kind as a pod, but here is a kind as a service because we are going to create the service. Here we are setting the name as a backend service. Then there are the types of the service. So there are three types of service. The first one is the cluster IP. Second one is I think load balancer, node node port. And here we are setting app and selector as a backend because we need to ensure that service are going to use the backend ports. So we are connecting those with each other using the service, and we are setting the port as a 80 and target port as a 87. So by using the command kubectl apply -app and the YAML file name, we are going to create the service and checking it using the command kubectl get service svc, and we can check that the backend service are created with the cluster IP this the port 8. So what's the next step? We verify the service. We are going to describe the service as well by using the kubectl describe service as a backend service. We are getting the namespace are the default one, and the selector we use as app at the backend, and type of the service is cluster IP. Then this is the IPs, this is the port, target port, and this is the endpoints of our service, and yeah, that's it. But what's next? We are going to use create the client port. So going to create the client port. I think we created the client port. Let's see. Still K port. I don't think so. But I think I have the file. Okay. I have one file as I already created. That's why I have this file. Okay, we just going to apply the changes, and these are creating the port for the client kubectl get port. So we are getting the 3 port. There's the app backend app 1, 2, and the client port. So what's next? We are going to inside the client port. So we are going to inside the client pod using kubectl exec hyphen it. There's an interactive mode, and the client, the pod name, and dash dash slash bin slash bash. This is our terminal. What happened? What happened? IT client port. Happened. I think yeah, this command is working. But what happened with this? I don't know what happened with this. Slash manually start. On such a file or the command terminated. Okay, we are going to use this terminal. No worries. So we are inside the client port, right? So we are inside of the client port. I'm going to show you again. Still get ports uctl exec hyphen it, then the client port, and then hyphen sh. We are inside the client port. So inside the client port, we are checking with the command called http :// and we are going to use the service name. The service name, what's our service name? Backend service. Curl not found. Okay. Curl not found. So I think we can use. Don't know what happened. Curl is not found. I think curl is not installed on this terminal. So we are. So what we need to do is we can use the wget as well, but I don't think so. I think we can use that bash bin bash. We can use the bin bash. Don't think so. Bin bash also work. Okay, let's see. We are using this command kubectl exec hyphen it. Then okay, what's the port name? Client. What happened? Unable to the container process. What happened? I don't know. Think, yeah. Let's check. Don't know what happened, but yeah, there is the another method. I think we can use that. I think I am having the permission issues. So we are going inside pod again. IT, then pod name, and then -sh. Okay, we are inside the client pod, and we can use the wget and check. So by using the wget command, we are giving the service name, that is a backend dash service, and we are getting the response like welcome to Nginx. So yeah, we proved that the what we proved that we can do the pod to pod communication using the service, not with the pod IPs. So yeah, we are the that using the command wget. So we firstly we use with the pods, we are use the IPs, but we are not going inside of the pod using the bin bash. So that's why we use the wget. It's a command line HTTP command that sends the HTTP request to an URL, and we get the response by using that. So IBAN Q is the quit mode and O is for the output. So that's and dash is the standard output of the terminal. So yeah, that's it. So instead of the saving the response to a file, we are just going to print it directly on the screen. So we are getting to print this response there by using the service name, that is the backend service. kubectl get service, and we have the cluster backend service kubectl describe the service backend service, and here is the name of our service, that is the backend service. By using that name, using the wget command, we are checking that the pod to pod communication is happened with the help of the service name. So yeah, that's it for this video. If you like this video, please like the video, and if you want to subscribe the channel, please subscribe it. And yeah, that's it for this lecture. Yeah, bye bye, thank you.